The 8th grade skill for the extension of finding volume with 3D solids is finding the volume for also cylinders. So think of your can of soup. We need to know how much soup to fill inside that cylinder. Looks just like this 3D solid right here. Okay, so think of your can of soup. We need to know how many perfect cubes fit on the inside of that cylinder. So these guys, we want to know how many perfect cubes fit on the inside of the cylinder, because that's why we label our answers cubed. We want to know how many cubes fit inside. Well, if you look right at the edge, like right there, there's some curvature to it. And you're probably thinking, well, how does that fit? How does a perfect cube fit inside of a cylinder? That's why you got to use pi again. And we all know what pi is. 3.1415. It's an irrational number that doesn't repeat. It goes on forever because circles go on forever. And we use it to multiply to these formulas to help solve for that curvature of the rest of the 3D solid. So here is your formula. Volume is the big B times H. And that big B, instead of a lowercase b, means that it's actually the area of the base of that cylinder times height. Okay? So when you're solving for the area of a cylinder's base, that's a circle, isn't it? So when you're solving for the base of that cylinder, it's a circle. So how do you solve for the area of a circle? The area of a circle, remember, is pi times the radius squared. So that's what we're using in replace of that big B. So I'm going to go ahead and draw number 1. And it's going to be a cylinder. Draw it best you can, just like Miss Chiano. I'm going to give you radius. The radius of that base, I'm just going to say, is 2 feet. All right, and the height of that whole cylinder is 4.5 feet. Again, you want to know how many perfect cubes fit on the inside of that cylinder. How many, when we stack them, will fit inside that guy? So I'm going to go ahead and write it. We need to know pi r squared for that big B spot times the height. That's what technically we're using. So let's write a new step on a new line each time. We're going to go ahead and solve or use substitution, and our radius is 2. So we're going to do pi times 2 squared, close the parentheses, times 4.5, which is the height. Let's go ahead and solve for it. 2 squared is 4, and pi 3.14, or I actually want you to use the pi button. So the pi button is right there, times 4, round to the nearest tenth. That 6 turns that 5 into a 6. So now you have 12 and 6/10, and we're going to multiply it to 4.5 times 4.5, and you get volume, which equals 56. That 8 turns that 4 into a 5, which turns that 5 into a 6. Okay, 56 and 6/10 feet cubed, because we're actually using cubes to see how many fit. So that's one example. Let's do one more just to be safe. Number 2, I'm going to turn the cylinder sideways this time. Just because, why not? You're going to see it in all different ways. I'm going to go ahead and give you a diameter this time too. The diameter is going to be 11 centimeters. Okay, and let's go ahead and say that the length of it is going to be 12 centimeters. All right. So again, we're using that big B times H, and that big B means the area of the base. The base is a circle, so we got to use pi r squared. So pi times the radius. Well, what's half of 11? That's 5.5. So 5.5 squared times the height of the whole cylinder, which is 12. So let's go ahead and solve 5.5 squared, which is 30 1/4. So now you have pi times 30 25/100, and we'll multiply that by 12 last. 30 1/4 times pi is this, 95, and you round to the nearest tenth. That 3 leaves that 0, so we're just going to leave it at 95. So now you have 95 times 12, and you get your volume, which is 1,140 4/10 centimeters cubed. Now, if you need to round to the nearest hundredths place, if the directions were to tell you that, that's fine. Okay, it would be 9. That 9 is that hundredths place. However, that 8 turns that 9 into a 10. It would be 0.4. 4D. We need to make sure we know how to round. And that's solving for the volume of cylinders using volume equals the area of the base times the height of the whole